We will move on to the fifth sum, which is totally different, dealing with the integration, checking for causal or non-causal property of the system. Y of t equal to integration minus infinity to t x of tau into d tau. Check for the system property causal or non-causal. So integration, if this the sum is like this, then what you need to do is you need to change the parameter tau to the variable what we know t. If you are changing that to the value of t, then what happens? T is already minus infinity to t x of t into dt. So what we know about the integration? Integration is nothing but area under the curve of x of t for the values of minus infinity to t. Integration is nothing but area under x of t, the curve x of t, for the value of t from minus infinity to plus infinity. So we are, say for example, the signal to be like this, any random signal, any signal like this, x of t, and for this example only we are taking the x of t like this, and for the value of t minus infinity to t at present value, say it is equal to 1. So minus infinity to t, the limit is going from minus infinity to t. At any time, if you are seeing the curve, the area under the curve will be like this. At any time, it depends on, for example, at t equal to 1, it depends on the present value of input plus the past value. The area depends on the present value of input and also on the past value. Okay, based on this integration definition, we can write up that as area, integration is area under the curve. So the output at any time depends upon, for this example, it depends on present and past input. So the given system is said to be causal. Though the system given question is being complex, but the answer is very simple. Integration is the area under the curve for the values of t minus infinity to t. Anytime if you are checking at t equal to 1, depends on the past and present value of input. So the system is said to be causal. A similar example, the integration, we have actually 3 methods of working at. This is the first method, integration area, finding the area under the curve. And second one, check the property of the system, causal or non-causal, for y of t equal to minus infinity to t plus 1 x of tau into d tau. So here what is the value of t? T is t plus 1. Okay, so you need to change tau to t plus 1. For simplification of integration purpose, we need to change, what about the t value? We need to change it into tau. So y of t becomes minus infinity to t plus 1. X of tau into d tau becomes what? X of t plus 1 into d of t plus 1. Okay, if t equal to 0, x of t plus 1 you take it, x of t plus 1 you take it. If t equal to 0, what happens? X of 1, it becomes a t equal to 0, it depends on x of t will become x of 1. So at present value of input t equal to 0, it depends on the future input. X of t plus 1 is the term when we are replacing the tau by t plus 1. Y of 0, the output y of 0 at t equal to 0 will be depending upon the value of x of 1. Okay, so this is the thing where minus infinity, for x equal to minus infinity, it depends on the past input. So the system is, for the system is t plus 1, the given system depends on the future value of input. So the system is said to be non-causal. System is said to be non-causal. Similarly, I repeat the last step alone. We are replacing tau by t plus 1. So we get y of t on left hand side and right hand side integration minus infinity to t plus 1. x of t plus 1 into d of t plus 1. Okay, integration is nothing but finding the area and finding the value. So for example, t equal to 0, only one value we are taking it. Even if one value, the system is found to be non-causal, the total system will be non-causal. T equal to 0, y of 0 becomes x of 1. So if t equal to 0, y of 0 equal to x of 1, which is a future value. T is 0 is the present value, x of 1 is the future value, so future input. So the system is non-causal. But similar example, for t equal to minus 1, the system is causal. This is left to you. You can find out the answer for this. This is also very simple. T equal to tau equal to t minus 1. So at any time it depends on t equal to 0, x of minus 1. So past value of input. So the system should be causal. You can write the answers here for that sum.